and when I take this marker to the America or another country, then the mass remains constant. Mass remains constant. Its mass doesn't get changed. And when I take this marker to the moon, the value will be same. Hello everyone. Welcome to Incredible Study. Today in this lecture, we are going to study about variation in g. Here small g means acceleration due to gravity. And before this lecture, I have already released 6 lectures. And in previous lectures, we have discussed about the derivation of the formula of acceleration due to gravity. And in previous video, we have also discussed about the acceleration due to gravity. What is acceleration due to gravity? And in this lecture, we are going to deal with the change in acceleration due to gravity with various causes or factors. Similarly, next topic, that is mass and weight. These two topics, variation in g and mass and weight, we are going to study in this lecture. So without getting delay, let's start our lecture. Here our topic is variation in g. These are 3 subtopics: variation in g on the earth surface, variation of g with height, variation of g with depth. Let's take first topic. Go through the first topic. Our first topic is variation of g on the earth surface. As we know, earth is not a perfect sphere. Okay, it means the shape of earth is like orange. It means the earth is compressed from upper region and lower region. This is the shape of earth. This is the shape of earth. Okay, earth is similar to this shape. And we know the formula of gravity, acceleration due to gravity is given by formula of acceleration due to gravity is given by g is equal to capital G capital M by R square, where capital G is universal gravitation constant and capital M is mass of the earth, where R is radius of the earth. And in previous lectures, I have discussed about this universal gravitational constant. So if you haven't watched the video, then go and watch it, because this lecture is extremely dependent lecture to the previous one. Therefore, here this is called equator. This is called equator and this is called pole. This is pole and this is equator. As you are looking here, since the earth is in compressed shape, this equator, the radius at the equator of the earth is greater than the radius of the pole. Okay, it means, you know that this is radius of the earth at equator and RP is the radius of the earth at pole. Here we can figure out from the figure RE is greater than RP. Since mass of the earth is constant, it means mass doesn't get changed here. Therefore, acceleration due to gravity is inversely proportional to R square. It means when radius of the earth increases, the value of acceleration due to gravity decreases. When radius increases, acceleration due to value of acceleration due to gravity decreases, and when radius decreases, the value of acceleration due to gravity increases. This is the relation between radius of the earth and acceleration due to gravity. Radius of not only earth, any planet. Okay, here g is inversely proportional to the r square. It means when the value of radius is greater, then the value of acceleration due to gravity will be minimum, and when the value of radius will be minimum, then the value of acceleration due to gravity will be maximum. From this we can conclude that radius decreases at equator and increases at pole. Since radius of the earth at equator is greater than the radius of the earth at pole, the value of acceleration due to gravity is maximum at pole and minimum at equator. Okay, right. We are now I am going to write it purely as acceleration due to gravity is inversely proportional to the r squared. As acceleration due to gravity is inversely proportional to r squared, since radius of the earth at equator is greater than the radius of the earth at pole, the value the radius of the earth at equator is greater than the radius at pole. The value of acceleration due to gravity will be maximum at pole and minimum at equator. Of the earth. We have discussed our first subtopic, that is variation of g on the earth's surface. When the radius of the earth increases, it means radius of the earth is greater at the equator. The value of g will be minimum, and when radius of the earth at the pole is smaller, then the value of acceleration due to gravity will be maximum. So one question is there: objects falls faster at the pole than at the equator. Why? Can you give the answer? The same answer. As we know, acceleration due to gravity is inversely proportional to radius of the earth. So we know radius of the earth at the pole is less, so the value of acceleration due to gravity will be more. Let me write here. Here we know the question. The question is: object as we know, the value of acceleration due to gravity increases when the radius decreases. So we can directly write here the value of acceleration due to gravity at pole of the earth is this much, and that at the equator is 9.78 meter per second square. From this we can conclude the velocity of the object increases at pole. So objects fall faster. Here, this is the answer of this question. Objects fall faster at pole than at the equator of the earth. Why? This is the reason. The value of acceleration due to gravity at pole of the earth is 9.83 meter per second square. You can note down it because this is the maximum value, and that at the equator is 9.78 meter per second square. This is minimum value of acceleration due to gravity at earth. The velocity of the object increases at pole. Since the acceleration due to gravity is more, the velocity of the object increases at pole. So object falls faster at pole. Okay. Now we move to our next subtopic, that is variation of g with height. What will be the change in acceleration due to gravity with height? Our next topic is variation of acceleration due to gravity with height. What will be change in height? Acceleration due to gravity with height. What is variation of g with height? As we know, let me draw the figure. Suppose this is earth. This is the radius of the earth. Okay. Earth, and this is radius. If the object is placed over here, then you are asked to find the acceleration due to gravity at that place. Okay. Therefore, the object is placed at certain height, from Earth's surface. It means this is kept at certain height. Let this height be h. Okay. Then we find here the value of acceleration due to gravity when the mass and radius of the earth is given. As we know, the formula of acceleration due to gravity is capital G capital M by R squared. Okay. So now formula will be capital G capital M by R plus H whole square, because the height is added in radius. So this will be at denominator. Here, when the height increases, the value of denominator increases. It means here we know when the mass of earth is constant. Okay. Therefore, here it is inversely proportional. It is inversely proportional to 1 plus R plus H whole square. It means when the value of height increases, when object is kept at height, then the value of acceleration due to gravity decreases. It means acceleration due to gravity decreases with the increase in height. Okay. Yeah, we can write acceleration due to gravity. Acceleration due to gravity, that is small g, decreases with height. This is our second topic. We have also finished this one. And one very important formula, if you are asked to find the value of acceleration due to gravity at this place. When mass of the planet is not given, then what will you do? Here, or mass of the earth is not given, then there is formula. As we know here, the formula of acceleration due to gravity is capital G capital M by R square. Let this be equation 1. And here acceleration due to gravity at certain height is what? The formula is this one, capital G capital M by R plus H square. Let this equation be 2. Now we go to the simplification. It means when just divide this equation by this equation, you will get, what will you get? G by G is equal to capital G M by R plus H whole square by capital G M by R square. Here we can see here this GM and this GM will be crossed to each other. Then here G inverse by G is equal to R by R square by R plus H whole square. It means G, the value of acceleration due to gravity at certain height, will be R by R plus H whole square into acceleration due to gravity. This is very important formula and it is very useful for numericals. Now we move to our next topic, that is variation of G with depth. What will be the change in acceleration due to gravity with depth? Now we go to our topic, variation of acceleration due to gravity with depth. That is variation of acceleration due to gravity with depth. What will be the change in acceleration due to gravity with depth? So here is simple. Suppose draw this. This is Earth, figure of Earth. Let this is Earth. This is center and this is radius. This is radius of the Earth. Here, now we understand, when suppose this object is kept at here, at this surface of the Earth, and when we take this object below the Earth's surface, suppose we have taken this object here, then we draw here circle from this. Considering this is the center for this circle also, this will be the shape circle. And we while finding the value of acceleration due to gravity, we only take the mass of this circular object only, a small circular region, okay, and radius will be this much. As we know, acceleration due to gravity is dependent to mass of the Earth and radius. It means when mass increases, radius or acceleration due to gravity also increases, and when radius decreases, acceleration due to gravity increases. In this case, we can see here mass of the Earth is changing. Mass of the Earth is changing. It means the mass of is decreasing. So the value of acceleration due to gravity also gets decreased. Therefore, we can conclude here the value of acceleration due to gravity decreases with depth. Okay. And now we move to our next topic, that is mass and weight. Before this, I want to deal one question. What is the acceleration due to gravity at mountain? It means one give reason question. Why the value of acceleration due to gravity is less at Mount Everest than in the Tara region? So the fact is same. The reason is same. It means when we go up, when we go at the Mount Everest, the height from the sea level increases, and when height increases, the value of acceleration due to gravity decreases. Since acceleration due to gravity is inversely proportional to the r plus h whole square. When this height increases, the value of g decreases, and when height decreases, the value of acceleration due to gravity increases. It means that at the Tara region, the height is less, and at mountain region, the height is maximum or more. Therefore, acceleration due to gravity decreases at Mount Everest and increases at the Tara region. So now we move to our next topic, that is mass and weight. Now our topic is mass and weight. Here mass. What is mass? In your junior classes, you might have studied the definition of mass. Mass. The definition of mass is the total amount of matter contained in a body. It's called mass. Suppose this is a body. Then the matter contained in the body, it means the molecules. Mass of molecules will be the mass of this object. Okay, it means the mass is the total amount of matter contained in any object or any body. That is the mass of such object. Now we go to its detail. Then you need not to learn many things about this mass. You just only know definition, units, and what type of quantity it is. It means definition I have told: total amount of matter contained in a body. Total amount of matter. Total amount of matter contained in a body. This is mass. Next one, the SI unit is kg. It means kilogram. Mass is scalar quantity. Scalar quantity, and here it is constant quantity. Here about mass we are going to study. It means we have studied the definition of mass. The SI unit of mass is kg. It means kilogram. This is the SI unit of mass, and mass is scalar quantity. It means mass have only magnitude. Okay, and here this is constant quantity. It means the value of mass does not get changed. Wherever you go in the universe, the mass of the object remains constant. Suppose the mass of this marker is 1 kg. Then when I measure the mass of this marker at the earth, then its mass will be, that is 1 kg. 1 kg. And when I take this marker to the America or another country, then the mass remains constant. Its mass doesn't get changed. And when I take this marker to the moon, the value will be same. Even I take wherever in the space or in the universe, the mass of this marker will be 1 kg. That is called constant quantity. It means mass doesn't get changed place to place. It never get changed. Now we move to our next topic, that is weight. What is weight? As here mass we have discussed, the mass of this object is m. When the object is attracted by the force that is called gravity, by the force that is gravity, then this gravity changes into this, the combination of this both will be weight. Combination of this both will be weight. It means weight is the force exerted by gravity on a body. The force is exerted by this gravity on a body, that is, this is of mass m. So the mass of this body will be mg. Here W is equal to mg. Weight we are discussing. Okay, it means value of weight is directly proportional to change in acceleration due to gravity. Now we discuss here. Since weight is a kind of force, its unit will be Newton. Unit is Newton. First one. Second point, it is a vector quantity. Vector quantity. Now you ask how it is a vector quantity. Wherever you go on the Earth's surface, Earth always attract any object towards its center. When I put this object, then it attracts the object towards center. When I put the object here, it attracts towards center. When I put the object here, then it attracts towards center. Even when I put here, it attracts the object towards center. It means the direction of this force is always towards the center of the Earth. From this, now we can conclude here, weight is a vector quantity. Okay. Now we move to the topic that is variation in weight. What will be the change in weight? What are the factors that changes weight? Now we discussed weight. What is weight? We have discussed the definition and unit and what type of quantity is it. About weight. Now we discuss the variation in weight due to various factors. First one, due to change in acceleration due to gravity. As we know, the formula of weight is mg. It means weight depends upon the mass of the object and acceleration due to gravity. When the acceleration due to gravity here, mass is in weight is in directly proportional to the weight is directly proportional to acceleration due to gravity. When the value of acceleration due to gravity increases, the value of weight also increases, and when the value of acceleration due to gravity decreases, weight also decreases. It means weight changes due to the change in acceleration due to gravity. The value of acceleration due to gravity increases, weight decreases. Decrease in the value of acceleration due to gravity cause decrease in the weight also. So we can conclude here, weight is directly proportional to value of acceleration due to gravity. Now we go to our next topic, that is carried from equator to pole and vice versa. What will be the change in weight when we carry any object from equator to pole and pole to equator? As I have told you, the value of acceleration due to gravity at pole, is 9.83 meter per second square, and the value of acceleration due to gravity at equator is 9.78 meter per second square. It means the value of g is maximum here at pole, and the value of acceleration due to gravity is less at equator. So now we can conclude the weight will be maximum at pole because the value of acceleration due to gravity is more. Here mass is constant. Only acceleration due to gravity is changing. When we carry any object from equator to pole, the weight of the object increases, because increase in the value of acceleration due to gravity cause increase in the weight also. Okay, now we move to the next factor, that is above and below Earth surface. What will be the change in what will be the change in weight when we carry any object from above from the Earth surface and below from the Earth surface? Here, when the object is here, when we carry above, here above means at certain height and below means at certain depth. It means we have studied under this topic, these two topics, that the value of the acceleration due to gravity decreases with the increase in height and increase in depth. When height increases, the value of acceleration due to gravity decreases, as is inversely proportional to height. It means r plus h, and g is inversely proportional to depth. When depth increases, the value of g decreases. When the height increases, the value of g decreases. Since weight is directly proportional to acceleration due to gravity, when g increases, it means from these two cases we have concluded the one statement, that is the value of acceleration due to gravity decreases with height and depth. So we can see here, when we carry object above the Earth's surface or below the Earth's surface, its weight also decreases. Now we move to next question, that is next topic, that is Earth to Moon. When object is carried from Earth to Moon, what will be the change in weight? We know here acceleration due to gravity of the Earth is 9.8 meter per second square. 9.8 meter per second square. This is the constant value of acceleration due to gravity of the Earth. And the value of acceleration due to gravity of the Moon is 1.63 meter per second square, which is almost 1/6 of the value of acceleration due to gravity of Earth. It means here gm is here, gravity of Moon. Gravity of Moon is 1/6 of value of acceleration due to gravity. It means here this is 6 times of Moon. This is almost 6 times. The value of acceleration due to gravity on the Earth is almost 6 times than that of the Moon. It means the object weighting, or the object weights, suppose the weight of the object at Earth is 100 Newton. 100 Newton. 100 Newton. Then what will be the change in the value of g? Then let this be 600 Newton. Then the value of weight on the Moon will be 100 Newton, because we know weight is equal to mg. Weight is equal to mg. Okay. Now suppose the object is 10 kg. 10 kg, and we have taken value of g, that is 10. This is constant value for the Earth. Okay, no need to worry, you can take this 10 also. Suppose we have carried here weight and mass 10 kg and gravity 10, so this mass 60 kg, then it will be better. 60 into 10, 600 Newton. And when at the here Moon, 60 into 1. It means almost 1.5. This will be 30. Or 30 or not 30 not. It means this will be 100, almost nearly about 100. So here we can conclude what is here we can conclude the weight of body decreases when carried from the earth to moon, as weight depends upon acceleration due to gravity. The value of acceleration due to gravity at the moon is less than that of the value than that at the earth. So weight of any object decreases when it carries from earth to moon. In this way we have completed this about these topics in this lecture. And in this lecture we have studied about two topics, that is variation in acceleration due to gravity and variation in mass and weight, not variation in weight due to various factors. Two topics we have discussed: variation in G, mass and weight. And under this we have discussed these topics. And one very important question that is you are frequently asked in your examination, that person jumping 1 meter on the earth jumps 6 meter on the moon. How it is possible? It means since the value of acceleration due to gravity of moon is 1/6 of the earth, when the person jumps 1 meter, when person jumps 1 meter on the earth, it jumps 6 meter on the moon. Okay, because the force of attraction by the moon on the body is less, so the body can jump more high. Okay, therefore this is very important question. And one question also: a person lifts 10 kg on the earth, can lift 300 kg or something kg is there. Okay, that is also due to acceleration due to gravity. And in this lecture we have discussed these two topics. In another lecture we will discuss about free fall and weightlessness. So for this lecture only this much. Thank you for today.